Good morning, guys. In this video I'm going to show you how to drive the Handerson equation for acidic conditions. So in this case you're reacting a weak acid, which is hydrochloric acid, reacting with water to form hydronium ion and the conjugate base. So what it is here is water is acting as a base, this one is acting as an acid, and we are forming a conjugate acid and a conjugate base. But since hydrochloric acid is more weaker than water, so it's like water is adding a proton to hydrochloric acid to form a conjugate acid and a conjugate base. So water is acting as an acid. So to write this, we are going to consider writing a Ka expression for a weak acid, which is Ka is equals to the concentration of the product, which is hydronium ion concentration, multiplied by the fluoride ion divided by water is a pure liquid, so we're going to consider an acid, the concentration of hydrofluoric acid, like that. Then from here we are going to introduce logs. First, before we do that, we know that the properties of log can help us break this, right? So when you introduce the logs to the left hand side and the right hand side, so we say introduce negative logs to both sides. So what you're going to do, you're going to have negative log of Ka is equals to negative log of hydronium ion concentration multiplied by the fluoride over hydrofluoric acid, like this. Then from there we are going to split this one. We know the property of log can help us split this into different sides. So we're going to have negative log of Ka is equals to negative log, we get hydronium ion plus, since there is a division here, we're going to subtract minus negative log of fluoride ion over hydrofluoric acid as your case. Then according to the formulas from here, we know that pKa is equals to negative log of Ka. So where there is negative log of Ka, we put pKa. So we're going to have pKa is equal to, then we know pH is equals to negative log of hydronium ion. So wherever there is a negative log of hydronium, we put pH. So we're going to have pH minus log of fluoride ion divided by hydrofluoric acid. Then since we're interested in the pH, this equation is used for calculating the pH of buffer solutions. So we're going to take this side here so that we make pH the subject of the formula. So we're going to have pKa plus log of fluoride ion divided by hydrofluoric acid is equals to pH. So we can still rearrange it as pH is equals to pKa plus log open bracket fluoride ion over hydrofluoric acid. So when you look at this is your conjugate base. So it's like you have pH is equals to pKa plus log open bracket base over acid. So that's how we get the equation for the Handerson-Back equation. So this is for acidic conditions. These are acidic conditions. Thank you.